This is CNN Breaking News.
And welcome to CNN. Breaking news. There has been a new development in the land of hydrocarbons. In today's news, the coast of India is facing horrific oil spills that two ships collided with each other and loss of petroleum has leaked. This is bad for aquatic animals because it covers their coats and it's bad for their lungs and their gills. If they ingest the oil, it's very poisonous. A biochemist stepped in and pitched the idea for the officials of India. Dr. Ahmedos is a well-renowned biochemist who devotes his life to cleaning up oil spills. He proposed a dispersive chemical that breaks up the oil particles and makes them into small molecules. They're called dispersants and acts like soap, breaking up the oil into tiny droplets. These droplets are then eaten up by bacteria in the sea. However, many dispersants are toxic chemicals and should be used sparingly. Have you ever wondered why the United States, Canada, Russia, and China have all rebooted their mission to Mars project? Well, the answer lies beneath Mars' surface. That's right, scientists have finally discovered oil on Mars. Data collected from soil samples sent from the Mars rover clearly shows a mixture of alkanes, cycloalkanes, and aromatics in Mars soil. This is proof that Mars contains so much crude oil that it's starting to seep through the surface. So it's time to get ready, get set, and let the space race begin. And now it's time for our advertisement.
Come on down to Dave's Hydrocarbon Warehouse. We've got reactor deals on hydrocarbons of all kinds. For only $9.95, you can get yourself a single bonded alkane, anything from a CH4 to a decane. If that's not enough, we have double bonded alkenes starting at $11.95. These hydrocarbons with double bonds are even more reactive than the regular alkanes. If two bonds ain't enough, we've got you covered. For a limited time only, you can buy yourself a highly reactive military-grade alkyne. Yes, sir, you heard me. That's a Y&E on the end. These bad boys are reactive as they come. Get yours today for $31.97. That's not all, folks. We've got something for the ladies as well. We've got hydrocarbons that come equipped with a benzene ring. That's C6H6 for anyone wondering. These state-of-the-art aromatics smell great. Your wife will love them, or you can get your money back. That's Dave's satisfaction guarantee. Come on down and give us a visit. We've got hydrocarbon for any need. Terms and conditions apply.
This is CNN Breaking News.
Coming up tonight, here's a sneak peek on an exclusive interview with a member of a Japanese scientist who was part of the discovery of new plastic-eating bacteria that could save the Earth. I'm here with Mr. Chang, one of the members of a group of Kyoto scientists who have just recently discovered a new strain of bacteria that feeds off plastic waste. Mr. Chang, when did your group discover the strain, and what's the name?
We first came across this discovery about 5 years ago while rummaging through piles of waste after studying 250 different samples of material. We finally isolated a single microbe that lived by consuming polyethylene terephthalate, PET, which is a common plastic used in bottles and clothing. The new species of bacteria has been named Idenella saccastines. I know, it's weird. After the location of where it was found.
Has this bacteria always existed without our knowledge?
We are not entirely sure, but believe that because plastics have only been around for less than a century, the microorganisms may quickly evolve to adapt to the material and could still evolve further to the point that it will be able to consume certain types of specific plastic fibers beyond PET.
Why would the bacteria be attracted to plastic as a food source?
Plastics are created from carbon-based monomers, which is good for microorganisms such as bacteria, because carbon makes up most of the main cellular materials of a bacterial cell with a dry weight amount of 50%.
An estimated of 342 million tons of plastic are produced annually worldwide, with waste that lingers in the environment, streets, fields, and waters, because particles are hard to degrade. Why are these not degradable?
Polypropylene is not naturally made by nature, so that organisms that break down natural plastics have harder time because they do not recognize this new material.
How does the bacteria break down PET?
We discovered that bacteria secretes two different enzymes that degrades plastics and have been able to identify the gene that is responsible for the PET digesting enzyme. One enzyme works with water to break down the plastic into an intermediate substance, while the other enzyme broke it down to PETs, basic building blocks. This makes the bacteria first strain that has the potential to degrade PET completely into carbon dioxide and water.
Does it take for the plastic to degrade?
Normally, on their own plastics can take centuries to degrade. Through our test, we have determined that the temperature of 30 degrees Celsius, the bacteria could break down into thin film of PET after about 6 weeks. With further studies, we could find ways to shorten the speed of degradability and improve the strength of the enzymes.
Last question. How can the bacteria be used to dispose of the water waste?
By learning more about the enzymes and how they are produced, we can find out about their chemical makeup and manufacture them ourselves to use against plastic waste. Manufactured enzymes are already in use, so the idea of genetically engineering bacteria integrating their enzymes is not far behind. We can also work to recycle PET by letting the enzymes break down into simpler chemicals which could then be used to make new plastics.
Thank you for your time, Mr. Chang. For more information and the whole story, we'll be back at 9 at 8. Coming up, it's time for our Jeopardy game show. Welcome, ladies and gentlemen, to tonight's game show. Tonight's contestants are Rowan and Justin. Tonight's theme is Chemistry Wonder. Okay, ready? So please, Rowan, please choose your turn.
Could I have $100 for the picture?
State and define what type of hydrocarbon this is. Okay. Correct? And that is correct. Justin, please choose your
200 local choice.
Choose one of the following to define your field group.
ZA.
That is correct. 200 for Justin. I have 200 for Christian. Please define this.
Okay.
That is also correct.
$100 for definition.
100 for definitions. A process in which the solvent is added to.
Solvent.
That is correct. Justin, you have your final choice. B is correct. And now back to Justin for the news.
Breaking news. On March 10th, scientists Pavlov, Demikov, and Nikolai Korsakoff discovered 4 new hydrocarbons: ester, carboxylic acid, alcohol, and halocarbon. An ester is an organic compound made by replacing the hydrogen with an alkyl to make an acid. It is used in perfumes and essential oils, in food flavorings and cosmetics. A strong acid catalyst is needed for esterification, which is the process of making esters. Next, the carboxylic acid. This acid is an organic acid containing a carboxyl group. It is used in butter, soap, and chocolate. Next is alcohol. It is formed when yeast ferments. And a hydroxyl functional group is bound to a saturated carbon atom. It is used as a solvent and fuel. Lastly, a halocarbon. A halocarbon is a hydrocarbon with a halogen in place of a hydrogen. These are used in pesticides, solvents, and other elastomers.
This just in. There are more than just 4 functional groups for hydrocarbons. They are structurally different and therefore have their own naming rules. Start with the ethers. These hydrocarbons don't have functional groups, but instead an oxygen that is bonded to 2 hydrocarbons. This works because an oxygen can have 2 bonds. The hydrocarbons are are named as alkyl branches. You commonly name the whole molecule with the longest functional group, followed by the latter group, then ending it with an ether. So this molecule is a propylethyl ether. Next, we have aldehydes. Aldehydes each have a carbonyl group, which is composed of one carbon, one hydrogen, and one oxygen. Bonded to the carbonyl's carbon is a carbon chain. When naming this hydrocarbon, the carbon chain is treated as an alkyl branch and includes the carbon of the carbonyl. Instead of the -il ending, it has an -al. If there are more branches attached to the carbon chain, it is added to the beginning of the name. The number in front of the corresponds to the location of the branch. In this case, we have 3 carbons, so we call it propan, and we add an -al to signify that it's an aldehyde, so we have a propanal. It is really close to naming alcohols, except without the oic or the acid. Propanal, not propanoic acid. Like an aldehyde, ketones also have a carbonyl group. The difference between the two derivatives is that the number of carbon chains on the functional group. Ketones have 2 carbon chains as opposed to 1. Naming is similar to aldehydes except with 2 carbon chains being considered as alkyl branches. The shorter branch is written before the longer branch and is ended with an -one or ketone. So in this case, we have a propyl and a methyl. So we'll start off with the methyl and then a propyl and ending with a ketone. So this is a methyl propyl ketone. Next are amines. This hydrocarbon derivative contains the functional group amino. The amino group's nitrogen is bonded to a carbon chain. A nitrogen bonded to only one alkyl group is a primary amine, with 2 is its secondary amine, and when bonded to 3 is a tertiary amine. This is possible because a nitrogen can be bonded to 3 separate molecules. To name this specific hydrocarbon derivative, start by numbering the carbon chain from the carbon closest to the amine group. The beginning of the name corresponds to the number of carbons are on the alkyl group. The location of the amino group, as it relates to the numbering of the carbons, is written next, followed by an amine. So in this case, it's a heptan to amine. Last but not least are amides. Their structures are composed of amide groups that resemble carbonyl groups. Instead of an oxygen bonded to a hydrogen, it is a nitrogen bonded with a maximum of 2 other molecules. Its nomenclature is similar to alcohols, so much so that taking a similar alcohol and changing it to a few letters gives us the amide's name. Change their oic acid into an amide instead. If there is a carbon chain on the nitrogen, then add that to the front of the altered alcohol name. To indicate its bond with the nitrogen, write N in front of the carbon chain. So in this case, there are 3 carbons, so it's a propan. And then we have 1 carbon here on the nitrogen, so it's a methyl. Since it's bonded to the nitrogen, then it's N-methyl propan amide.
Tuning in for tonight's segment. Have a good evening.